In this lesson, we're going to look at how to factor by grouping. So let's start out by thinking about, what if you had to factor a polynomial and the common factor was not a single variable but a binomial? Like this one, x times y plus 2 plus 5 times y plus 2. So in this case, the common factor is y plus 2, is this whole parentheses, x times something plus 5 times the same thing, and so the y plus 2 is common. If we factor out the y plus 2, that will leave the x and the plus 5 in another set of parentheses. Now if you think about distributing this whole y plus 2, not as a FOIL operation, but just distribute the whole thing as one chunk, you could have this whole parentheses times x and this whole parentheses times 5, and that would get you back here. So this really is the factoring, and you can see that this is now in factored form because it's this binomial times this one. This is very similar to any other common factor. It's just that we now have a binomial. So let's take the same problem, but instead of x times y plus 2, we'll say x times z plus 5 times z. So all I've done is replace the y plus 2 with a z. So you would have no trouble factoring out the z here, and it would leave x plus 5 in parentheses. Well, we've done the same thing over here with y plus 2. So just to remind you, it looked like this, x times y plus 2 plus 5 times y plus 2. If you factor out the y plus 2, it leaves the x plus 5 in the other pair of parentheses. So just for practice, let's factor x squared times x minus 3 plus 5 times x minus 3. Now both of these terms have an x minus 3 in them. So if we factor out the x minus 3, that's going to leave x squared plus 5 in parentheses. Alright, here's a different one. Same idea. X times y plus 9 minus 7 times y plus 9. Both terms have a y plus 9. And that will leave x minus 7 in parentheses. So remember that factoring means to write the thing in multiplication form. Now that we've practiced factoring out binomials, let's talk about factoring by grouping for real. This is a way to factor when you have 4 terms and no common factor. So this method only works, you should only attempt it when you have 4 terms. There are 3 steps. Here they are. You're going to factor the GCF from the first 2 terms. Then you're going to factor the GCF from the last 2 terms, and they won't be the same. And then you're going to factor the common binomial, if there is one. So when I say there's no common factor, I mean there's no common factor for all 4. But you'll find that the first 2 have a common factor, and so do the last 2. And the result is 2 binomials that are in factored form. Now let's factor x cubed plus 4x squared plus 3x plus 12. First off, look at the first 2 terms. We could factor x squared from them, and if we do that, then in parentheses we'll have x plus 4. See, because x squared times x gives you x to the third, and x squared times 4 gives you 4x squared. Now look at the last 2 terms. What can you factor from them? Well, they both can be divided by 3, so let's factor out the 3. And that will leave x plus 4. Now we've got this situation where we have a common binomial. Both terms have an x plus 4, both groups have an x plus 4. And so if we factor out the x plus 4, that will leave x squared plus 3 in the other set of parentheses. Now if you wanted to check yourself, you could use the FOIL method and multiply these 2 binomials back together, and what you would find is you would get these 4 terms back as a result. Okay, here's another example for us to work on. X to the third plus 5x squared plus 2x plus 10. Now, if I look at the first two terms, I can factor in x squared, and that will leave x plus 5 in the parentheses. And if I look at the last two terms, I can factor out a 2. And that will also leave x plus 5 in parentheses. Now both groups have an x plus 5, so let's factor out the x plus 5. And that will leave x squared plus 2 in parentheses. And again, as a check, if you were to use the FOIL method on these two binomials, you would get back these four terms. Okay, now here's one a little different. This one, the second group starts with a minus, so we'll have to be careful when we factor out the final GCF. The first two terms, again, we can get x squared from the first two terms. Now when we do the second two terms, we will have to put a minus here. Okay, and the GCF is 2, so 2 goes into both of these. And so negative 2 times x gives us minus 2x. Now negative 2 times positive 6 will give us this negative 12. And it's very important to note that these two binomials must be exactly the same, or you can't do the next step. We're only able to do the final step because this is a common or shared binomial. If one's different from the other, then everything's off. But note that I needed this plus sign here because if I had a minus sign here and I distributed this negative 2 times negative 6 would have been positive 12. So we really need the plus sign in order to keep this negative here. Alright, now moving ahead, they both have an x plus 6. And so we get x plus 6 times x squared minus 2. So bottom line, every time you have a negative that starts the second group, you change this sign and continue. Here's one more. 3x to the third minus 2x squared minus 6x plus 4. So I can get an x squared from the first two terms, and that will leave 3x minus 2. This is a negative here, so I'm going to start the second group with minus. I can divide both of these by 2. Now, in parentheses, negative 2 times 3x would make minus 6x, and negative 2 times negative 2 would make plus 4. So again, because I have a negative out here, I'll have to change this sign. And now they both have a 3x minus 2 and an x squared minus 2. So notice again what factored form means. It means that we have binomial times binomial, or polynomial times polynomial. In other words, there's not a plus sign in between these. Factored means you have it separated into multiplication parts. Okay, one more thing. If there is no GCF for a group, you should use a 1. As in this example, let's have 6x to the third plus 8x squared plus 3x plus 4. So if I look at the first two terms, I see that 6 and 8 can both be divided by 2, and I can get an x squared here. So I'll have 2x squared. In parentheses, that is going to leave us 3x plus 4. Now for my second group, I can't get a common factor. So I put the two terms that I do have in parentheses and use a 1 as the coefficient, because after all, if you distribute a 1, you're going to get these two terms back. So it's perfectly legal to do that, but that makes it look right so that we can do the next step. Now, if we look, they both have a 3x plus 4. And in my next set of parentheses, I'm going to get 2x squared plus 1. So having that 1 there helped me know what to put here. So again, anytime there's no common factor for two terms, you simply put them in parentheses and stick a 1 in front as their coefficient. So here's another example of that. 35x to the third plus 15x squared plus 7x plus 3 these two have common factor of 5x squared, and these two don't have a common factor at all. So if I factor the 5x squared from the first two terms, that's going to leave us 7x plus 3 in the parentheses. Now these two don't have a common factor, so I'll still put them in parentheses, but just put a 1 in front of them. Now factor out the 7x plus 3, and that will leave 5x squared plus 1 in parentheses. Now, I've said it a couple of times, but still, here it is in writing. You can check your work by multiplying the binomials back together. In this example here, if we use FOIL and multiply this back together, 3x times 2x squared would be 6x to the third. 3x times 1 will be 3x. 4 times 2x squared will be 8x squared. And 4 times 1 will be 4. So these are not in the same order, but they are all the same terms from the problem, and so they represent the same thing. So we know that we did the factoring correctly.